Alright, welcome back. Now we're going to be looking at factoring before we simplify it. And how to do this is essentially we're going to have a set of algebraic fractions, and let's see if we can make them any simpler before we start working with them. And one of the ways we do this is to factor out common factors in both the numerator and the denominator. So if we look up the top here, we can see that we do have a common factor between both of these terms, and we can factor by grouping. So if I rewrite this by dividing, by essentially putting a common factor at the front, which is 2, and dividing each one of these terms by 2. So 2p divided by 2 is just p, and 2q divided by 2 is just q. All over p plus q. Alright, if I expanded this, I just end back up where I started, so they're just equivalent and I've just rewritten them. And one of the things to note is p plus q can be considered a factor as well. 1 times p plus q and 2 times p plus q, which means both the numerator and the denominator are being multiplied by the same factor, which means we can cancel both of them. And we end up with 2 over 1, which is just 2. So that makes it a lot easier to work with, and definitely is worth doing if we're going to be doing any operations involving that initial algebraic fraction. Alright, next one is 3t minus 12 all over 2t minus 8. This time we're going to be doing it to both the numerator and the denominator, and we're going to take out common factors in both. Now both the top values, their coefficient and the negative 12 are both multiples of 3. So let's bring out the 3 out the front. 3t divided by 3 is just t, and negative 12 divided by 3 is negative 4. All over, well, 2t and 8 have a common multiple of 2, so bring the 2 out the front, and then do 2t divided by 2 is just t, and negative 8 divided by 2 is negative 4. Again, we have this common factor here that we can cancel, and then we're left with 3 over t. Right, so let's get rid of those now. Question 3, we have x squared plus 3x all over 3x plus 9. Now, with this first one, the common multiple between, or the common factor between these two is going to be our pronumeral. That's the only thing they have in common. And we should be considering both the coefficients of both the numerical values and the pronumeral when we're doing this. So let's take out their common factor, which is going to be x, and then x squared divided by x is just x, and 3x divided by x is just 3. Next, looking at our denominator, what's the common multiple here going to be? Well, it's going to be to do with the numerical values of 3 and 9. And if we look at them closely, we can see that they're both divisible by 3. So I will bring the 3 out the front, divide 3x by 3 and get x, and divide 9 by 3 and get 3. And on the whole, again, I have this common factor. Remember, these are multiplied. And because of that, I can cancel both of them. They're both being multiplied by the same thing, which means I can divide both the numerator and the denominator by it to get x over 3. And that's a lot easier to work with, and that's why we have to do this. Alright, let's get rid of all of this, and let's have a look at this one. So we have a, a all divided by ax plus ay. Alright, so we're trying to cancel, and these questions kind of lead you towards an obvious solution. So at the top we essentially have a, and then in the bottom we have our two essentially common multiples. So if a is being multiplied into both, we can bring it out the front as a common factor. an ax divided by a is just x, and ay divided by a is just y. And then we have our a up the top. And you can also think of a as essentially a times 1. So let's do that just for illustrative purposes. So we're both multiplying the top and the bottom by a, which means we can cancel, which leaves us with 1 over x plus y. You don't have to do the times 1 here. It's just to prove a point. Alright, next one, we have 3a squared minus 6ab all over our 2a squared b minus 4ab squared. And remember, we are going to do this basically from factoring both the numerator and denominator separately. Okay, so what's our common factor here going to be up the top? What do they have which is common between both terms? Well, they both share the pronumeral a. They both have coefficients which are multiples of 3. What don't they have in common? The b. So the b is going to stay. We're not going to be able to do a common factor of that, but we are going to be able to factor out the 3, and we are going to be able to factor out at least one of the a's. Let's bring 3a out the front, and then dividing 3a squared by 3a, we're just left with a. And dividing 6ab by 3a leaves us with 2b. Okay, let's look at the ones now down the bottom and see what we've got if we have a common factor. So we notice also we have common factors in our coefficients down here. And we also share common pronumerals of a and a. But importantly, we also share common pronumerals in terms of b. So our factor, or our number we're going to bring up the front here, is going to be slightly different. So we'll bring up the 2, we'll bring out an a, the common multiple between a and a squared. The lowest one is, the highest common factor is going to be a, and the highest common factor we're going to get between b and b squared is going to be b. So 2a squared b divided by 2ab just leaves us with a, and then 4ab squared divided by 2ab leaves us with minus 2b. And looking at that, they are both being multiplied by the same factor, so we can cancel both of them and be left with 3a over 2ab. But that's not enough. We've also got this common factor of a between them, which means we can also cancel both of these a's and be left with 3 over 2b. Okay, that was a little bit complicated, but the same rules apply all the time for these types of questions. It just takes a little bit longer for some of them than others. Alright, let's look at the next one. X squared plus 2x all over x squared minus 4. Right, so common factor at the top is obviously x. X squared divided by x is x. 2x divided by x is just 2. All over our x squared minus 4. Now, if you remember that when we have something like this, where we have one number squared minus another number squared, or another square, it's called difference of squares. And difference of squares always ends up to be our first number, not squared, plus the square root of our second number times the first term square root minus the second term square root, every time. So when we're looking out for these types of simplifications, we're definitely going to look at difference of squares as very important in identifying a way to factor and ultimately break something down into a way that we can look for a common factor to cancel. And in this case, there is a common factor. Both the top and the bottom are being multiplied by x plus 2, so we can cancel both of them and be left with x divided by x minus 2. So by noticing these patterns of difference of squares, or where we have or using the concept of perfect squares, or using our factoring of quadratics, we can make these a lot simpler. All right, next one, we have a squared minus 9 all over a squared plus a minus 12. Right, let's deal with the numerator. So we know the top is going to be difference of squares. So it's going to be a minus 3 times a plus 3. That's all done. The second is a quadratic, and we are going to factor that using a few steps. The first thing is to assign values to each one of these letters. So because we don't have any coefficient out the front, like a 3 or something like that, we essentially have a monic quadratic. And because it's monic, we are looking for values that are essentially going to add to this middle term's coefficient and multiply together to give negative 12. So we have to be looking for sum equals 1 and the product equals minus 12. All right, let's bring up a widget for that and have a look at find a number there. So we need numbers that add to 1 and multiply to negative 12. All right, so think about your product first. Think about what numbers are going to multiply to give negative 12. When it's negative, it means 1 has to be positive and 1 has to be negative. And because our middle term is going to be positive, that means when we add these together, when we sum them, then positive 1 has to be larger than the negative 1. All right, so what's our numbers that we can get that have a product when multiply is going to be 12, and then we'll deal with the sign in a moment. So there's 12 times 1, but if I sum those together, that wouldn't get us there. But there is 3 times 4. Okay, 3 times 4 is an interesting way of looking at this. So let's say 3 and let's say 4. Now, the other thing we have to think about is if we have the sign on this one as negative 3, okay, then we'll end up with the sum being negative 3 plus 4, giving us that value of 1, right? If we did it the other way, and we summed these together, 3 minus 4 would be negative, so we wouldn't get to add to 1. So the sign is really important in this one. And we've got negative 3 and 4. Right, so negative 3 and 4, they add to 1 and they multiply to give negative 12. So let's write them down here. So we have negative 3 and 4. Okay, so we know that. And why is that important? Well, it means we've given, essentially, we're able to rewrite this quadratic as a minus 3 times a plus 4. So we can see how each one of these numbers essentially informs what is going to be next to it in these two brackets, right? We're going to end up with a minus 3, a, and this is a positive 4, and it tells us what goes there. So this becomes this once factored, and we can do the math on that, but ultimately we've got a lesson on that. You can go back and look at it if you want to, but it's quite time consuming, so we'll just leave it there for now. And now that we have our factored numerator and denominator, we can look for common values, and we have one, a minus 3 and a minus 3, which leaves us with a plus 3 times over a plus 4. And that's our answer. Now, if you don't remember how to do this kind of factoring of a quadratic, you can use the quadratic equation, or you can go back and watch one of our earlier videos. Okay, let's have a look at another one. Right, so we are starting right off the bat with another quadratic that needs to be factored, and another value here which also needs to be factored. So let's look at our first one. We have to make sure that it's going to add up to positive 2, and it's going to be multiplying to give positive 1. All right, those are our two things that we needed to do. So let's bring up our dreaded widget, and let's go to the next one. So it has to add the 2 and multiply together to give 1, right? And they're both positive, and that's helpful because if they're both positive, that means we can either have 2 negative numbers multiplied together and added together, or 2 positive numbers. In this case, it's going to be 2 positive. So what 2 numbers add to do and multiply to 1? What is the factors of 1? 1 times 1. So this is just going to be 1 and 1, right? They multiply together to give 1, and they add together to give 2, right? So it's just going to be 1 and then positive 1, and it's also going to be positive 1. Right, so that's done, and that's a really easy one, and you don't really have to think too hard on it. But that also means it's a perfect square, right? Which means we end up with x plus 1 times x plus 1, or x plus 1 squared. Now you can leave it like this if you would like to. It's more useful like this to begin with, just in this setting, but ultimately this is the same as x plus 1 squared. And you can notice that by remembering what we have, what the perfect square formula is. All right. Next one here, we have x squared minus 1. That's difference of squares because we have 1 times 1 and x times x. So x plus 1 times x minus 1. All right. Now let's cancel common factors. 1 and 1, and we're left with x plus 1 over x minus 1. Okay, and we're done. Right, here's our last one. So we have two quadratics to factor here. I guess I was feeling ambitious and didn't think about how long this video would take to do. X squared plus 9x plus 20. So we've got 2 sets of numbers here that we have to think about, and let's get started. So we have to find values that add up to 10 and that multiply together to give 25. Right, so what's that going to be? But also, it's worth noting that maybe we have some sort of perfect square here as well. Right, what are those 2 numbers going to be? And we can also just note that what's the formula going to be for perfect squared is a squared plus 2ab plus b squared. So if we have a square here and a square in term 3, it's very likely that what we have is a perfect square. And that means we can just divide this middle term by 2, and if it does equal essentially a number which then squared produces 25, we don't have to worry about it. But let's do the full thing here. So 2 numbers that multiply together to give 25, and that add together to give 10. Oh, that's not 1. Right, so what are they going to be? What 2 numbers multiply together to give us 25? Well, price 25 are 25 and 1 and 5 times 5. So if I do 5 and 5, when I add them together, I will get 10, and when I multiply them together, I will get 25. And because of that, I have got a perfect square again. right? It's going to be x plus 5 times x plus 5, which means we just end up with x plus 5 squared. But it's useful to keep it as x plus 5 times x plus 5. All right, looking at the next one, we're looking for values that add to give us 9, or sum to give us 9 rather, and also that multiply together to give us 20. Right. So that one's a little bit more annoying to do, but let's bring up our widget again. And we'll look at 9 and 20. What are our factors, or how we multiply to a product that will produce 20? Well, two numbers can multiply. So 20 times 1, 5 times 4, 2 times 10. 5 and 4. 5 and 4 is interesting because if I give you 5 and 4, we add them together and we get 9, and we multiply them together and we get 20. So this is the ones we're looking for. So we've got 5 and 4, and because of that, we end up with x plus 5 and x plus 4, and we're done. So once we determine these, and their signs are very important, we can just add them in to these two brackets. Right, now that's done, let's look for our common factors. Well, x plus 5 and x plus 5 go, and we're left with x plus 5 all over x plus 4. And that's our answer, and that's the last question, thank God. So if you need any more help, there is a separate video on this content on factoring quadratics and non-monic quadratics. So go back, have a look at that if you need help. But that's all I have time for today. Hopefully it was helpful, and I will see you in the next one.